Okay, in this question, they tell us that there are 20 girls, 13 of them take history and 8 are taking econ. 3 of them are taking both, which we can see right here in the middle. It says P and Q represent the number of girls. So first it says find P. Well, it tells us that 13 take history, and we know that this circle right here represents everyone that's taking history. So there's already 3 girls here, and there's 13 in the history circle, so that leaves 10 for P. Then it says find Q. Well, Q, in order to find Q, we have to know how many girls are in this whole little circle section on its own, and then Q is everything left over from that. So it says 8 take econ. Well, again, if there's 8 in this econ circle, and there's 3 right here, that leaves us 5 in this space over here. So we know there's 5 here. We already said we know P is 10. So that gives us a total of 18 girls that are taking either history, econ, or both. So how many girls are taking neither? Well, there's 20 total. So that leaves us with Q being 2. And then it says, a girl is selected at random. Find the probability that she takes econ but not history. Well, we need to go ahead and find where is the group that's taking econ but not history. This is the group taking econ, but these 3 are taking history. So the group that is not taking history is this whole area over here. Just those 5. So there are 5 girls that take econ but not history. And there's a total of 20 girls. So that's the probability that she takes econ but not history. Now, in probability, in general, IB is not requiring you to reduce your answers, but in other things they are. So if you did reduce this to 1/4, that would also be correct, but you would not have had to. Okay, so in this question, they give us a probability distribution table, and it's important to know that in a probability distribution table, everything that's in the top row right here, that lists the possible outcomes in a certain scenario. So that means that in this scenario, you could have an outcome of a 1 or an outcome of a 2. And then in the bottom row right here, that represents the probabilities of those outcomes. So there's a probability of the outcome 1, the probability is cosine of theta. For the outcome of 2, the probability is 2 cosine 2 theta. Now again, that doesn't look like what we're used to it looking like. We're used to these being numbers, but eventually we can find out what those numbers are. If you have a probability distribution, you have to have, it's a requirement that you have all the options laid out in front of you in this. You can't leave out any of the possible outcomes. So that means that everything in the bottom, all of these probabilities, those need to always add up to be 1 because it represents all the possible outcomes, 100% of the outcomes. So we can actually write an equation that says cosine of theta plus 2 cosine of 2 theta must equal 1. And that's true of any discrete probability distribution table like that. Well, now we have a trig equation to solve. We can't solve it the way it is because we have cosine of theta and then we have cosine of 2 theta. And since they're not like terms, we can't just combine or anything like that. So we are going to have to use a trig identity from our formula sheet. There is a trig identity for cosine of 2 theta. In your formula sheet, it gives you 3 options. You can replace it with cosine squared minus sine squared, 2 cosine squared minus 1, or 1 minus 2 sine squared. Well, to me, since we already have a cosine in this equation right here, it makes the most sense to replace it with the one that has just cosine to make our lives easier. So we are replacing this right here, cosine of 2 theta, with this right here, 2 cosine squared theta minus 1, because they are equal to each other according to our formula sheet. So now we are going to distribute. So we have cosine of theta plus 4 cosine squared of theta minus 2 equals 1. And hopefully, when you're thinking about your trig equation strategies, the first one is, can you solve it outright? Which we can't. The second one is it a disguised quadratic? Which it is. Because right here, we have a single item, and then that item being squared. So we just have to rearrange it so it looks like a quadratic. So I am going to make sure it's in the right form. 4 cosine squared theta plus cosine of theta, and then I'm going to subtract 1 from both sides, so that's minus 3 equals 0. And when we look at that, some people find it to be really helpful to replace cosine of theta with a variable, and just for the sake of factoring or solving with quadratic formula. And if that helps you, that's great. So then we have to factor. And you can use whatever factoring method you prefer. And we need it to be plus 1 minus 3. Okay, so there's our factored form. And then once we do that, we can put the cosine back. So we now have 4 cosine of theta minus 3 equals 0. And we have cosine of theta plus 1 equals 0. And when we solve that, we get cosine of theta equals 3/4 and cosine of theta equals negative 1. But cosine of theta can't be negative 1, because if it was, that would mean the probability of 1 is negative 1. And we know we can't have negative probabilities, so we can cross that off. And this is our only solution for cosine of theta. It's important to note that when you have a question that says show that, that means that you couldn't have used 3/4 at all in the problem. You had to just solve and work your way to getting 3/4 as an answer. So now we've shown that cosine of theta is 3/4, and now it says find tangent of theta. So we know what cosine is. We also know one rule for tangent of theta is that it's sine over cosine. So we do know cosine is 3/4, but we don't know what sine is. So we're going to have to pause on the tangent and focus on finding sine. We have to look at our trig identities, and there's a trig identity called the Pythagorean identity that says that sine squared of theta plus cosine squared of theta equals 1. So that means that 3/4 squared plus sine squared should give us 1, and that's what allows us to solve for sine of theta. So that's plus 9 over 16 equals 1. So now we have sine squared of theta equals 7/16. And we're going to take the square root of both sides. So that tells us sine of theta equals plus or minus the square root of 7 over 4. Now, the key to figuring out whether sine is positive or negative is looking right here at the fact that tangent of theta is greater than 0. So if tangent of theta is greater than 0, that means sine would have to be positive here so that tangent is positive. So we can go ahead and plug in square root of 7 over 4. And now we can find tangent of theta. But remember, dividing by a fraction is the same as multiplying by the reciprocal. And so these 4's cancel out, and we just get square root of 7 over 3 as our final answer. Okay, so when we take a look at this problem, it gives us a function f of x, it gives us a function g of x. It's asking us to find f to the negative 1 of x. And the first thing we have to do is figure out what does f to the negative 1 represent. And hopefully when you think back to our previous units, you remember that that means inverse. So we're looking for the inverse of the function. It's not the derivative, because the derivative uses those tick marks to represent prime, but that's not a tick mark, it's a -1. So inverse means that we are going to reverse the rule. So instead of having x be the input and y be the output, we are going to switch them so that y is the input and x is the output. So what I mean by that is we take this function f of x, which says y equals 5x, and we are going to replace all y's with x's and all x's with y's, and then solve. So we would divide both sides by 5, and we get that the function inverse is x over 5. Okay, and then the next question asks for f of g of 7, and so that little o, that represents this. Take the function g of x and plug it in for x in the function f of x. So the function g of x is x squared plus 1. And then we know that function f of x is 5 times x, but instead of x, we're going to replace x with x squared plus 1. And so that's going to give us 5x squared plus 5. And it doesn't say find f of g of x, it says find f of g of 7. So we are going to plug in 7 for x. So that gives us 5 times 7 squared plus 5, which gives us 245 plus 5, which gives us 250. Okay. Okay, so this question looks at our triangle and circle knowledge from geometry. And a couple people have asked, when we've looked at problems like this before, if they are able to do a problem where they say like, oh, well, tangent equals opposite over adjacent, or sine equals opposite over hypotenuse. We can't do that unless it's a right triangle, and we know that this triangle is not a right triangle, so we are only limited to using the law of sines or the law of cosines to find missing sides and angles. Sometimes you might use the area of a triangle formula to find missing sides and angles, but you can't use the regular right triangle trig if it's not a right triangle. So looking at this problem, we know that we have 30 degrees here, and we're trying to find PR, which is right across from it. We also know we have 45 degrees here and 13 as the side across from it. So whenever we have a side and the angle across from it, so we have a matching set, and then we have another set that is only half complete, that is how we know we're using the sine rule. So we're going to set it up. We're going to say x goes with sine of 30 degrees, as 13 goes with sine of 45 degrees. And sine of 30 is something that we know from our unit circle. We know that at 30 degrees, sine is 1/2. And we also know that sine of 45 here, that's root 2 over 2. Once you set it up, there's a couple different ways that you might decide to solve it, but I'll just show you one of them. We know that we can multiply, do a cross multiplication, so that would give us root 2 over 2x equals 13/2. That's just one way to do it. And then I would go ahead and multiply both sides by 2, because that cancels the 2's out. So we have square root of 2 equals 13. So we get x equals 13 over the square root of 2. And that's our answer, except we, in general, try not to leave radicals in the denominator. IB is less picky than other places, but still, we can multiply by square root of 2 over square root of 2 to get 13 square root of 2 over 2 as our final answer. Okay, so this question is a real-world problem. It says Jim heated a liquid until it boiled, and then he started measuring the temperature of the liquid as it cooled. So the first thing it wanted to know is the independent variable. That's the thing that we are changing, and then measuring how that affects the change on the dependent variable. So the independent variable is time. Or minutes. And then our dependent variable is the temperature, because the temperature depends on how much time has passed for it to cool. Okay, so for this part B, it says write down the boiling temperature of the liquid. Well, one thing that we are aware of is that it says that D is the temperature T minutes after it boiled. So that tells us that it boiled with no time passed, and then it started cooling. So the temperature when it boiled was 105 degrees Celsius. Then it says Jim believes the relationship can be modeled by a linear regression. He describes the correlation as very strong. If it is very strong for a correlation, we know that it's either going to be close to +1, which would be this, or close to -1. So either close to this +1 or close to -1. That would be strong. A strong correlation is close to 1 or -1. A weak correlation is close to 0. And then we also can tell when we start looking at the table, as the x values are going up, the y values are going down. So if we were to graph that, as the x values over here are going up, the y values are going down. So that it was a negative correlation. So that means it has to be this, -0.992. Last part says Jim's model is, and he gives us his model, use the model to predict the decrease in temperature for any 2-minute interval. So we have to look at the model and ask ourselves which of these represents the decrease in temperature. We know that this 105 represents the starting temperature when time is 0. So this right here, the slope, that's what's representing how the temperature is decreasing. So this slope says that it's decreasing -2.24 degrees per 1 minute. Well, we want to know what it is for 2 minutes. So we can just take that and multiply by 2 to get -4.48. It is decreasing 4.48 degrees per minute. Per 2 minutes, sorry. So that was just seeing if you knew how to interpret the line of best fit. Okay, so question 6 is tough, but looking at it, it tells us that this is a geometric sequence, which means that we know that it's being multiplied from one term to the next by the same common ratio to get the next term. Now, when I look at that, I don't see anything immediately coming to mind as far as what can be multiplied. But I do remember that there are log properties that can allow us to rewrite things like these logs. One of the properties for logs says that if you have a power here on an exponent of this x, this argument, we can actually take this exponent and move it to the front. So I'm going to do that. So now my sequence looks like this. Well, now when I look at this, what am I multiplying by each time to get to the next term? Well, to get from 16 ln of x to 8 ln of x, I'm multiplying by a half. Same thing when I get from 8 ln of x to 4. So my common ratio is 1/2. Okay, now when I saved it as a PDF, for some reason, it kind of off-centered the argument of the summation, so I rewrote it how it should look. Hopefully it looks like that on your paper. When we look at this one, we are identifying what is x, because it's telling us to solve this equation. We know we'd be thinking about whether we're solving for either k or x, but we're not solving for k because this tells us that we start with k equals 1 and go to infinity. So we're not solving for it, we're solving for x. This summation right here, all this is saying that this is the summation of this function, where we start by plugging in 1 and we end at infinity, which we know we can't do. So a summation generally is just representing a series, either a geometric or arithmetic series of some kind. So what I would encourage you to do with some of these, if this was a calculator question and it didn't have this x value, we could just type it right in. But we don't have that, and we have to just reason through it with our brains. So the first thing I'd recommend you do is to just write out your first few terms of the sequence. So if I plug in 1 for k, I get 2 to the 5 minus 1, 5 minus 1 being 4, ln of x. That is my first term of the sequence. Then my second term of the sequence is what I get when I plug in 2. So then I get 2 to the 5 minus 2, so that's 2 to the third, ln of x. Then I would plug in k equals 3. 2 to the 5 minus 3, so that's 2 squared, ln of x. So now I can start to look at this sequence and try to figure out how to best approach it. We know that the sum, because that's what this means, of this whole series all the way to infinity gives us 64. Well, anytime we're summing to infinity, that should bring to mind the formula we did for geometric series where it sums to infinity. So that formula says that S, the sum to infinity, equals u sub 1 over 1 minus r. Now this formula only works, first of all, if it's geometric, which we'll have to confirm, and also it only works if the absolute value of r is less than 1. So let's think about this. Is this a geometric series or sequence? If it was, when we would be multiplying this times something to get this, and then multiplying this times the same thing to get this. Well, basically the ln of x is the same every time. So what about these 2 to the 4th? 2 to the 4th, 2 to the 3rd, 2 to the 2nd. So what we're doing every time is we're dividing by 2, which is another way of saying multiplying by 1/2, just like the last part. So it is a geometric sequence. The value of r is less than 1, the absolute value, so we can plug into this formula. The sum to infinity, which we happen to know equals 64 because it tells us that, must equal u sub 1. U sub 1 represents the first term, so that's 2 to the 4th ln of x over 1 minus r, which is that. And from there, all we're doing is solving. So we have 64 equals, that's 16 ln of x over 1/2. So now we're going to multiply both sides by 1/2, or there's a lot of different ways we could do this, but yes, let's multiply both sides by 1/2. So now that gives you 32 equals 16 ln of x. We divide both sides by 16, so we get 2 equals ln of x. And then this is a great review of our log properties. We know that ln is log base e. So if we make it e to the ln of x, sorry, that's an e, then that e to the ln is going to cancel. But if we do that to one side, we have to do it to the other. So then that does cancel, and that gives us x equals e squared. Next, we have a vector question. It says that some line L1 passes through the points A and B, and they give it to us. And they ask us to find AB. Anytime we're finding AB, we know we can find that by subtracting the position vector of B minus the position vector of A. The position vector of B is just the coordinates of B written as a vector. Position vector of A is just the coordinates of A written as a vector. So AB must equal 3 minus 0, which is 3, 5 minus 1, which is 4, 2 minus 8, which is negative 6. Then it says, hence, write down a vector equation for L1. We know that vector equations always take this form, where A is the position vector of any point that's on the line, and B is a direction or a velocity vector. It's just a vector that represents the direction of the line. Well, we know that if both A and B are on the line, the direction of the line is from A to B. That's AB that we already found. So it's very easy to write this equation. We can pick either A, the coordinates of A, or the coordinates of B. And then vector AB can go there. So for this one, it now gives us another equation of a different line, and it tells us that we know that they are perpendicular. So show that P equals 2. Anytime two vectors are perpendicular, the dot product of two vectors will be 0 every single time. So we just have to figure out which vectors represent the line, because we have one line, we have another line, we want to show that they're perpendicular. Well, we just need one vector that represents the direction of one line, another vector that represents the direction of the other line. So which vector represents the direction? Well, that's this vector and this vector. So we can say that the dot product of them, 3, 4, negative 6, dot product with P, 0, 1, has to equal 0. How do we calculate a dot product? Well, we're going to multiply 3 times P, 4 times 0, and negative 6 times 1, and we're going to add them all up. So that gives us 3P plus 0 minus 6 equals 0. So if we add 6 to both sides, we get 3P equals 6, so P equals 2. I don't know why this wrote this again. Not necessary. We can ignore that. Then it says lines L1 and L2, that should say, intersect at C, and they give us part of the coordinates for C. Find Z. There's a lot of different ways that we can do this. In general, if we were finding the intersection of two lines, what I would recommend that we do would be to set the equations of the lines equal to each other. So it would say 0 plus 3t equals 1 plus p is 2. So 2s. 1 plus 4t equals 13 plus 0s. And then the third equation, 8 minus 6t equals negative 14 plus s. And then we have a system of equations which we would solve for t and for s, and then we plug it in to get the point. But one of the things that I know is that this ordered pair right here is on both of the lines. So really, I can pretty much just say either t or s. We can pick either one. I'll just pick t. And say that the top, the numerator, 0 plus 3t has to give us 9, because they already told us they intersect there. So that means that 3t equals 9, so t must be 3. We can check that by plugging it into the second one right here. 1 plus 4 times 3 gives us 13. Well, that's right. So to find z, all we're going to do is plug it into the final one, 8 minus 6 times 3. So that'd be 8 minus 18, which is negative 10. So this one says find a unit vector in the direction of L2. So I wrote down L2, that's the first step here. If it's in the direction of L2, we have to decide, is that this vector or is that this vector? Well, this one always represents a point on the line, but not necessarily the direction. This is the vector that represents the direction. So we're really saying find a unit vector that goes with 2, 0, 1. There's a formula for unit vector. Basically, if this is vector A, you take 1 over the magnitude of the vector times the vector itself. So the key is to find out what is the magnitude. And the magnitude would be 2 squared plus 0 squared plus 1 squared, which would be 4 plus 0 plus 1. So that's the square root of 5. That's the length of that vector, but to get a unit vector in the same direction, we're going to multiply the vector 2, 0, 1 by 1 over the magnitude, 1 over the square root of 5. And that's just how we're always going to find a unit vector. Find the magnitude and then multiply the vector by 1 over that magnitude. So we could leave our answer like this, or we could leave it like this, whichever way you're happy with. Does not matter. And of course, we probably shouldn't leave the radical in the denominator, but I know that they would accept it on this problem. The last one says find one point on L2, which is square root of 5 units from C. So what we're going to do here is start by writing out C. C is this, 9, 13, negative 10. And we want to add square root of 5 units in the direction of that line. Well, how do we add square root of 5 units? Well, we actually have a vector from the last one that's a unit vector. It's the vector that represents 1 unit in that direction. So if I want to do square root of 5 units, this represents 1 unit, and so I want square root of 5 of them. So this is actually pretty convenient because when I multiply by the square root of 5, now all of a sudden it's just 2, 0, 1 again. So that gives us 11, 13, and negative 9. So this question is a quadratic question. We know because it says it's a quadratic function and it talks about the axis of symmetry. We have done a lot of different things with quadratics, both using a lot of algebra and just thinking about it visually. And this is one of those where you want to draw as much information as you can. It's telling you that the axis of symmetry here is 2.5. So if I were to sketch that, 1, 2, 3, 4. Here's 2.5. Here's the axis of symmetry. It also tells us a y-intercept of negative 6. So here's our y-intercept. It also gives us this equation, and there's something important here. Remember that this right here, those are the roots. So when we look at that, x minus 3 equals 0, that gives us one of the roots, x equals 3, which we can now draw. And then x minus p will give us one of our roots. So p is our other root. Well, when we think about this one, we have here this axis of symmetry right here. We know one of the roots is 3, so the other one has to be the same distance from the axis of symmetry. So there has to be the other root here at 2. So that tells us that p must be 2 because of the symmetry. So now we have an equation that looks like this, a times x minus 2 times x minus 3, and it says find the value of a. Well, what information haven't we used yet? We still haven't used this piece of information. We know that when you plug in negative 6 for y and 0 for x, you must get a true statement. Well, if you do that, now you have an equation with one unknown and we can solve. A times negative 2 times negative 3. So that gives us negative 6 equals positive 6a. So a must be negative 1.